So we are starting Unit 11 today, which is talking about circles. The first day is going to be some terminology review and some review on some other stuff that we've already done with circles. So the first thing we're looking at is some definitions here. So a circle is the set of all points equidistant from a fixed point called the center. And a circle contains 360 degrees. You probably knew both of those already. So the center point of a circle is exactly in the middle. So right here in the middle. On our diagram over here, which we'll be looking at also, the center would be point G. So our center is point G. A radius is any segment going from the center of the circle to the outside edge. So there's three radii here. The first one is going from G to F, the next one is G to L, and the last one is G to E. And again, you probably knew that already as well. So we have GF, GL, and GE as our three radii. Our next definition here might be new to you. So a chord is something that we haven't really talked about this year. A chord cuts a part of a circle off. So this chord starts on the circle, cuts part of it off, and ends on the circle also. So anything that slices a circle into two pieces but ends on the circle is called a chord. So over here on our diagram, we have a couple of things. So we have KL slices off part of the circle, and K and L are both on the circle. So KL is a chord. And there's another one over here that starts at F and cuts all the way across to E. So this is a chord also because it cuts part of the circle off. So FE is another chord, but that's a special chord because it cuts through our center G here. So FE is a chord. It's also called a diameter, which you probably already knew. So FE is also a diameter. A couple things about diameters. They are twice the radius, which you probably already knew. And all diameters on a circle are congruent, just like all radii on a circle are congruent. Some people might look at this and say, oh, we have another chord here that's CD. However, that does not end on the circle over here. D is a point off of the circle. So that's actually another piece, which is new. So we have another piece of a circle called a secant. And that's something that cuts part of a circle off, but it continues on in at least one direction. So CD does cut the circle, however, it continues past it, so that is called a secant. So CD is going to be a secant. And the last new piece is called a tangent, and it's a line that intersects a circle at only one point. So it doesn't cut any pieces off. Instead, it goes and touches the circle exactly once. So if you think about a basketball laying on the ground is the tangent. So in this case, BA would be our tangent. And where the ball is touching the ground, that would actually be called the point of tangency. So BA is tangent to circle G at point M. So point M would be our point of tangency. So those are the new definitions. There's some examples of them there. What I'd like you to do next is look at this next circle and pause the video and get some answers for each of these questions. So figure out what each piece is in this diagram using the letters. Some of them do have more than one, so make sure you take a second and look at all of the pieces that are there. So pause the video and resume when you are ready to go. Okay, so going through this a little quickly, our center for this circle is going to be at P. The radii of the circle are everything coming from the center out, so PA, PD, and PB. PA, PD, PB. The diameter of this circle cuts across the center, so AB. And there are two chords. AD slices off a piece, and AB, since it is a diameter, is also a chord. So AD and AB are the two chords. There is one secant starting at B and going to C. There is one tangent that touches the circle exactly one time at RE. And that tangent has a point of tangency at D. The last piece here, if AB is 14, they want you to find what DP is, this piece right here. Well, AB is a diameter, so we know that if AB is 14, that means that AP is 7 because it's a radius. And since DP is also a radius, it is congruent, making it 7 also. So those are the pieces of the circle. If you identified those well, that is awesome. If not, then make sure you take some time and look those over because you will need to know them as the unit progresses. The next thing here is called an annulus, and it's a ring-shaped region or the region lying between two concentric circles. So you've done problems like this already where you have to find the shaded area. So to do this, you would have to find the area of the outside circle, find the area of the inside circle, and subtract them. So since you've done that before, I'd like you to pause this and do that right now. Okay, so if you have done that, here is the solution. When you subtract the two, you'll end up with 81 pi minus 56.25 pi, giving you 24.75 pi, or if you put that into your calculator, you'd end up with about 77.75. The next problem here is a little more complicated. It has another annulus, but this time they give you the shaded area and they want you to find the radius. So what you're going to have to do is take the area of the outside circle, so that's pi r squared, which in this case is 2r squared, or 4 pi r squared. So what I did is I took this 2 pi here, I plugged it in as my radius, and then I squared the 2, squared the r, and I ended up with 4 pi r squared. From that, I am subtracting the inside radius, which is just pi r squared, because the inside radius is just r. So that's going to be minus pi r squared. And just for the heck of it, I'm going to put 1 pi r squared there. So if I subtract those, that's 3 pi r squareds. And I know that this is equal to 12 pi, because in the problem we have 12 pi units is the area. So what I can do is divide by 3 pi. Divide by 3 pi. My pi's will cancel, and I'll have r squared equals 4, and I can take the square root to get r equal to 2. But they want you to find the radius of the larger circle. Well, the larger circle has a radius of 2r. So 2r in this case would equal 4. So my larger radius is 4. That was a little more complicated. You found the area of the outside one in terms of r, found the area of the inside one in terms of r, and then subtracted them. So again, a little more complicated, but if you know the method of doing that, you should be able to get at least part of it done. The next two sections here are definitely going to be a review. So talking about circumference, which is the distance around the outside of a circle, and then area, which is the area inside of a circle. So along with circumference comes arc length, which is looking at a fraction of the circumference. So just a part of it, not going the whole way around. So arc length, as we've talked about already, is the measure of the arc over 360 times 2 pi r. Another way you might want to look at that, another way that formula can be written, is arc length over 2 pi r equals angle measure over 360 degrees. So arc length over 2 pi r equals angle measure over 360. That's what you get if you do some cross multiplication. So looking at this first one here, circle Q has a radius of 9 and an arc of 160 degrees. Find the length of AB. So why don't you pause the video, take a second and try number 1 and try number 2, and then we will go over them in just a second. Okay, so when you plug in the angle measure and the radius here, you'll end up with 160 over 360 times 2 pi times 9, which when you multiply that all out, you'll end up with 8 pi, or if you put the pi in your calculator, it'll be 25.13. So either 8 pi is the exact answer or 25.13 as the rounded answer. Looking at number 2. So you have a circle with an arc whose measure is 80 and the arc length is 88 feet. What is the length of the radius and the diameter? So we're going to take our angle measure, which is 80, and put that over 360 degrees. And we're going to say that times 2 pi r will give us 88 pi, which is our arc length. So if we multiply this first part together here, we'll end up with 4 over 9 pi r equals 88 pi. And then you can divide by 4 over 9 pi, or multiply by 9 over 4, and then divide by pi. Since we're using calculators, I think this is just as easy. But it's up to you what you want to do. Your pi's will cancel on both sides. Your 4/9 cancel out, and you'll have r equals 198. And since we're looking for the diameter, we're going to double that and end up with 396. So that is some circumference and arc length stuff. The next thing is going to be area of a circle and area of a sector. And this follows the same thing that we talked about earlier in the year, which is very similar to arc length. So area of a sector is the degree measure of the arc over 360, and you're going to multiply that by pi r squared. Or if you want another way to look at the formula, you can say that the area of the sector over pi r squared equals the angle measure over 360, if you'd rather look at it as a proportion. So what I'd like you to do now is pause the video, complete numbers 1 and 2, and if you're feeling squirrely, you can try number 3. And then when you're ready, resume them, and we will go through 1 and 2, and then go through 3 as well. So to find the area of this sector, we're going to take the angle measure, which is 110, and put that over 360. And we're going to multiply it by pi r squared. R in this case is 12 squared. So we're going to have 110 over 360 times 144, and that will give you 44 pi. Or if you put that in your calculator, it ends up as 138.23. So this is the exact answer. This is a rounded answer. Number 2, I'm actually going to use the other formula for this one, the one that uses a proportion. So that is going to have the arc length over pi r squared, and then x over, or the angle measure over 360. So our arc length here is going to be 36, is going to be 36 pi, and that's going to be over pi r squared, which in this case, since the entire circle is 144 pi, we're going to be over 144 pi. And that's going to equal our angle measure over 360. So we can cross multiply here, and I'll end up with 144 pi times x equals 12,960 pi. if I divide